All right, this is Honors Algebra 2 Pre-Calculus. We're doing 8.1 in Algebra 2. This is our second video. We're doing kinds of variation, and we're doing applications and word problems. So, yay, word problem. So, under certain conditions of artificial light, the exposure time required to photograph an object varies directly as the candle power of the light and varies inversely as the square of the object's distance from the light source. If the exposure time is 0.01 seconds, when the light source is 6 feet from the object, how far from the object should the light source be when both the candle power and the exposure are doubled? All right, so let's go ahead and set this up. So we need some variables, right? So the exposure time is a thing we want to know. So I'm going to use T for exposure time. All right, to varies directly as the candle power of the light. I'm going to use P for power. I guess I could have used C for candle power, but that's fine. And I'm going to use inversely as the square of the object's distance. I'm going to use D for the distance from the light source. All right, so here's what we know. We know that the equation we're looking at is that the exposure time, T, varies directly as the candle power, so that's Kp, and inversely as the square of the distance, so d squared should be on the bottom. So this is the equation we're looking for, right? If the exposure time is given here when the light source is 6 feet away, so we don't know the candle power, but that's okay, right? So here's what we know. We know that 0.01 equates to K times whatever the candle power is, right? I'm going to call it P naught, like whatever that candle power is, over a distance of 6, right? So I get that 0.36 equals K times P naught. What's tricky here, and if you want, you can solve for K by saying, hey, it's 36 over 0.36 rather over P naught, right? So where P naught is the current candle power, right? Because the problem is they never gave me the candle power, which is not cool, but they didn't, and it makes the problem slightly harder. So there's my constant K. That means that my equation is T equals K, sorry, that's not my K, my bad. My K is 0.36 over P naught times whatever the power is of the new candle location. So this is a number, right? 0.36 over P naught is a number, all over d squared. Okay. They say, how far from the object should the light source be when both the candle power and the exposure time are doubled, right? So the question is, what they want us to do is they want us to find D if the exposure time is doubled, so 0.02, and the candle power is double of whatever it was in our original problem, right? So that's essentially what they're asking us to do, to find D, and everything else will be a number. So if we were to plug in, we get 0.02 equals 0.36 over P naught times 2 P naught, all over D squared, right? And so what's going to happen is we're going to get 0.02 D squared equals, so the P naughts are going to cancel, right? And I'm going to get a 0.72. So I'm going to get that D squared is a 36, because that's what's going to happen when you divide 0.72 by 0.02. And sure enough, you're going to get that the distance is still 6 feet, which is not super satisfying, but that's the concept. So cool. There we go. All right, so that's the concept. There we go. All right, so let's try another one. Heat loss, H, in calories per hour through a glass window varies jointly as the difference D between the inside and outside temperatures and as the area A of the window, and inversely as the thickness of the pane of glass. Okay, so before you do anything else, it's worth figuring out what rather disgusting variation equation you get from this, right? So what we get from this is that the heat loss varies directly as D and A, right? Or jointly rather, but as both of those things, and inversely as the thickness. That's our equation, right? We're then given a bunch of values. If the temperature difference is 30, right? So then we're given that if the difference is 30, The heat loss is 9,000 calories. The area is 1,500 cubic centimeters, and the thickness is 0.25, right? So we're then asked to find H, so that we use these things to find K. So 9,000 equals K times 30 times 1,500 all over 0.25, right? So it's up to you how you walk through doing this. It really doesn't matter to me. There's a couple arguments. I would argue that you could either multiply the 0.25 over, which is totally fine. Like you could find a fourth of this, and that's totally okay. You can certainly use a calculator if you want. There are other options, though, if you would rather do the mental math. But I'm going to go ahead and multiply the 0.25 over. So I'm going to get 2250 equals K times, so you're going to do, essentially that's a 45 with 3 zeros, right? 45 with 3 zeros, because the 3 times the 15 would be a 45, and there's 3 zeros. So if you divide this, you get 0.05. So 0.05 is my K, right? Once I know that, I now know that the equation I'm using is H equals 0.05 dA all over T. So that's the equation I have to use, right? And then I'm given values to find. So I'm asked to find the heat loss, H, through the same area when there's a thickness and temperature difference. So H equals, so the temperature difference is now 15, the area is still the 1,500, and the thickness is now 0.2 centimeters, all right? And then basically I'm just gonna go ahead and clean that up. So we're gonna do 0.05 times a 15 times the 1,500, right? And then we're gonna divide that by 0.2. All right, and we get that the heat loss is 5,625, and because this is a problem with units, I need to make sure I have units, just like I did in the last one with feet. The heat loss should be measured in calories per hour. And that's it, right? So the thing to notice here is that when you're given a variation problem, it's going to be hard to miss that it's variation, because they're going to talk about varying jointly or varying inversely. And really the bulk of it is figuring out what that constant K is and then finding any values that you're asked to find. And that's sort of the bulk of the problem. So that's 8.1.